Okay. Ayub sir, we will start now.
Okay.
Jansi ma'am.
Yes, ma'am. Every sunset is an
Wait,
opportunity.
Ayub, just don't share. Yeah, just a second. Okay, now Ayub, gentlemen.
Yes, sir. Every sunset is an opportunity to reset and start a new day afresh. Good evening, everyone. The Department of Electrical and Electronics Engineering, AVIT, takes immense pride and joy in organizing the first event of this academic year, an international webinar on intermittent technologies in renewable energy. To begin this wonderful event, I invite Dr. L. Chitra, HOD to address the gathering.
Good evening to one and all present here. It's my great pleasure to join you all the international webinar on intermittent technologies in renewable energy. Today's distinguished chief guest of the day, Mr. Ayub, Energy Engineer, Ministry of Energy, Mining and Environment, Morocco. I welcome you, sir. On
Yes.
behalf of our management and our principal, Dr. K.S. Shanmuganathan, Vice Principals, Academics, Admission and Administration, on behalf of all the members of our management, I welcome you once again for this wonderful gathering. And our students are waiting very much eagerly to know what happens in the renewable technology in the Morocco. So we are all interested to have a very enthusiastic evening lecture today. And also this is our first international webinar conducted for our students. I wish all the students will also gather new innovations and new technologies whichever followed in various countries. So we wish to have all these interactions like international webinars. So I like to invite all the students of electrical and electronics engineering department as well as the students from other departments of mechanical engineering and electronics and communication engineering as well as faculty members of various institutes. So I once again I welcome you sir on behalf of our department and faculty member. Thank you sir.
Okay, thank you.
Thank you, ma'am. Now it's time to introduce our esteemed guest of today's evening. I request Mr. V. Ratan Kumar, Assistant Professor of EEE Department, to do the same.
Thank you, ma'am. So it gives me immense pleasure to introduce the guest for today's event and my friend Ayub Ibrahim, who got his bachelorate in mathematical science in the year 2010 and followed by his studies from Moroccan National School of Applied Sciences, where he got his engineering degree in the year 2015. He is presently working as energy engineering for the Ministry of Energy, Mining and Environmental Science since 2016. He is a certified CEM for American Association of Energy Engineers and also certified ISO 502, ISO 19011 and participants of various multi-seminars in Thailand, India, Lebanon and Tunisia. Basically, he is an electrical engineering and presently he is preparing for his PhD in energy efficiency. It's very great to have you on this occasion, sir.
Thank you so much. Thank you so much, Ratan. And I have a huge pleasure to be with you today and present to you, the energy situation in Morocco and also the energy situation in India and how can we, obtain some solutions to reduce the intermittency in renewable energy. So may I share the presentation?
Yes sir. Yes you can sir.
Okay. So thank you. First of all, I would like to thank you, all of you, and especially Mr. Ratan Kumar to invite me and giving me the opportunity to present today my experience to present the energy situation in Morocco. So we will proceed by this plan as you see now. First of all, I will talk about the country profile, my experience firstly, and then the energy situation in Morocco, then the Indian energy market, and the renewable energy. We have a lot of technologies, but I will focus on solar energy, especially the energy getting from light. And then we will talk about the intermittent in technology in solar energy and the methods of energy storage. So my name is Ayub Ibrahim. I am an energy engineer. I'm working right now in Ministry of Energy, Mining and Environment of Morocco. I get the CRM certificate, Certified Energy Manager from the American Association of Energy Engineers the last year. And I'm also certified in ISO 50002 and also ISO 19011. And my fields of experience, I have experience in energy engineering and electrical engineering and energy efficiency. So I'm from Morocco. Morocco is a country in the north of Africa. As you see, our capital is Rabat and our largest city is Casablanca. We are about 40 million, in the population, and our king is Muhammad, as you see, Muhammad VI, as you see in the picture. So as you see here, this is, the evolution of the energy profile of our country. We are similar in, energy per capita. We are the same with India. We are in 1,000, I think, 42 kilowatt hour per annum in the consumption per capita. But the evolution rate, for example, in India is about 6% each year, but we are only on 4.6%. So our total capacity installed is 10,000, up to 11,000 megawatt, and the evolution rate, as I said, is about 4.6%. The energy consumption in 2018 is about 37 gigawatt percent, and our rural electrification rate is about 99%. So as you see here in the chart, there is a, it's in French, but hydro is 60% from installed capacity. Eolian, which is wind power, is about 11.2%, and solar is 6.5%. And the same of each country, the thermal energy occupy a large, part of our installed capacity. So the mix of Moroccan energy, as you see here, in 2020 is about 42%. This is our goal to, inject and take into consideration the renewable energy. So as you see, by 2030, the coal will decrease from 36% to 21%, and will base it on wind and solar and hydro to attain our goal. It is 52% for installed capacity. So there is a difference between installed capacity and used capacity, because the renewable energy problem right now around the world is that is very expensive comparing to the nuclear and also to the coal. But also we are thinking to install nuclear stations, especially small modular reactors with the third generation, which represent a lot of norms which are too safe. So I was in India in Nice, and I passed about 1 month there. That's allowed to me to understand the Indian energy market, as you see, and acquire a lot of informations. As you see, the Indian market is in huge evolution by 2040. And you see here the electricity consumption will increase by 57% by 2040, and also primary energy. And the share global of energy demand will increase from 5% to, I think, to 1,921 by 2040. So which must that will put the Indian government in very huge and important challenges, and they must to recognize and reclassify and also take into account this evolution in their strategy. And we are talking here about the third largest electricity producer in the world and the 5th largest in the world in renewable energy capacity. Also, in the consumption, we are talking about the third largest electricity consumer globally. So that's what the Indian government, in my opinion, should should improve the energy mix based on renewable energy, and especially the solar energy. And I will show you the Indian map for the solar potential in India. So here's some numbers of the Indian mix. As I see here, the thermal is always constitutes the big part of installed capacity, but the renewable energy is too huge comparing to Morocco, as I said. And the target of also is the same by 2020 is the 2022, the same for Morocco. Approximately we have the same targeted as you have, but in very few numbers. So as you see here, the installed capacity, for example, for small hydro is 6%. The wind power occupy a huge part with 45%, and biopower, also the solar power, constitutes very huge. So to sum up, India's power market is the third largest, and we are talking about 360 gigawatt power generation installed right now in 2080, and about 65% of the total power is sourced from coal and oil gas, with also the growing is about 6% every year. So now I'm going to focus on solar energy to make you understand the intermittence of solar energy, and then the same example for the other energy. As you see here, the map of Indian potential solar. So India have a huge solar potential, as you see in the map, with the high solar radiation from 4 to 7 kilowatt hour per meter. So the solar energy, as you know, and as we study all, there is two types, the heat and the light. So the heat thermal applications like steam generations, and light electricity and lighting applications. And as you see, the visible spectrum give us the high yield and the high potential, the maximum potential, as you see in the yellow part and the red part, and also the fraction, the percentage of a fraction of energy. We are talking about 47%. So, and what is photovoltaic? That is photon or light generated voltage. So the photovoltaic is always producing a DC current when exposed to light. Yes, and as you see here, so the principle is the band gap for silicon is, for example, 1.12 electron volt, which means an electron needs to acquire that much of energy to free itself from the electrostatic force that ties it to its own nucleus to jump from conduction, or to jump into the conduction band. So when a photon with more than 1.12 electron volt of energy is absorbed by a solar cell, a single electron may jump to the conduction band. So we always searching for the perfect material to build our solar plant, and as you see, there is many band gap there is many, many types of materials, their band gap and cutoff wavelength. So the producer search to make the perfect panel always. So to sum up, when the photon creates a whole electron pair near the junction, the electrical field in the depletion region sweeps holes into the p side and sweeps electrons into the n side of the cell. So that's what we talk about. The p-n junction is equivalent to 0.0 volt potential. So this is how it's going. As we explained here, we have the n-type semiconductor with the plus and the p-type semiconductor with the, the minus. And when the sunlight goes on, the electron goes through the depletion zone, which give us the generation of electricity. So we are talking generation of electricity. So there is a lot of technologies, the monocrystalline, the polycrystalline, the thin film, and each technology has positive points and negative points, as you see. And we, for example, this type, sorry, I have to make this to here. This type of cell is the most commonly used and will continue to be the leader as you see a more efficient and cost-effective PVD technology is developed. So it's essentially is crystalline CP injection and efficiency of monocrystalline silicon. Solar cell has reached around 23%, and it's very good. We'll talk of course about the solar. And the second thing is the solar photovoltaic industry to reduce costs and increase production have led the development of new crystallization techniques. We need to diversify a lot of source to guarantee the perfect mix. We will never guarantee the perfect results, but we are looking for the perfect mix. So to sum up, four kinds of thin film cell have emerged as commercially important: amorphous Ca cell multiple junction, the thin polycrystalline silicon, copper, indium. This line, the cadmium sulfate heterojunction cell, and cadmium tellurate cadmium sulfate heterojunction cell. So this is, if we compare the efficiency of each cell, as you see here, we are talking about from 14 to 20% of efficiency. We're talking about monocrystalline silicon, and polycrystalline, we are talking about 11 to 15%. And the other also, you say we use them just for test, and maybe they will be perfect if we get some modifications. So how we manufacture the solar panel is very simple. The solar panel PV is manufactured from silicon as depicted below. The silicon is converted into ingots, which are then sliced into wafers, as you see here. The silicon wafers are then manufactured into solar PV cells that are assembled further into solar PV modules. SPV modules in the product which a consumer get with SPV system. And this is how the structure of PV model, the class, the polymer encapsulant, the cell, polymer encapsulant, composite wheel, barrier, and the frame to protect the solar and to keep it very straight. And this is the the famous curve of the solar panel, as you see here. We need also and always to look at the panel, description, to know the open circuits, voltage source circuits, voltage at max power, current at max power, and the peak power to, select the perfect material for our, for example, power plant, taking into account, of course, our weather conditions. And this is how the test is going. So I think in India, there is a nice National Institute for Solar Energy, which do the certifications of solar panels. And this is very, very important point because it allows us to get the perfect, choice, and also to not just buy everything. And we are still working for that in Morocco, but we have this procedure in Morocco, but we are trying to develop it in Morocco by, I think by the end of this year, I think. So the efficiency and performance of PV module primarily depends on quality of PV cell, quality of module in production, solar irradiation, operating temperature, light spectral content. So in this performance, as you see here, the quality of PV, we can control it. The quality of module production, we can also control it. But solar radiation, it's not controllable. That's where comes, the intermittence. I will show you the figures that show that. So, I'm sorry, the operating temperature and light spectral content. So the power output increases as insolation increases, current increases proportionally. So this is very, familiar. I think the power, the description or the curve of voltage current of panel, it's famous, and also it influenced by temperature, as you see. For example, in zero, it is not the yield of 75 Celsius per, the the performance is not the same. That's very, it depends on temperature. So, but here we chose, how we can connect the PV module if we want the sum of voltage or the sum of, as you see here, if we want the sum of the currents, we connect them parallel. And if we want the sum of, V, the voltage, we connect them in series connections. And if we want them all, we can connect them in series and then in parallel, or the vice versa. So this is the technology of maximum power point tracking, and it's based on an algorithm which takes into account the installation direction of each country, and then we program, like a PLC controller, which will control a motor, or a robot. We can use, for example, just simple Arduino, for example, if you know the Arduino, or PSC control to to direct this panel to get that the maximum performance. So concerning the connected, this is not connected solar or simple solar PV system. It contains the PV array inverter, which is very important, and the rain mountain structure balance of system component. As you see here, we have to invert, and then maybe we can inject in the not in the connection, but we injected just in home. The difference between component of simple solar PV system and the other system that we will see, which is connected to grid, is the type of inverter. The first is a simple inverter, but the second is a smart inverter, which will allow to to inject and put the electricity on the grid, taking into account the frequency and characteristics. So the different PV system types: without battery backup, with battery backup, AC system, DC system, hybrid. This is all in standalone system, and the second in the grid connected system. So for example, this is a sample direct drive PV system. This is the simple DC PV system with battery storage, and this is EC PV system with the inverter with the batteries, of course. This is a hybrid PV generator system. And so if we want, of course, to connect with the grid, as I see here, we have to have a smart inverter, as you see here, and utility of connected on-grid system. So as you see here, this is the intermittency, for example, of solar energy. From 6 a.m. to 6 p.m. As you see in the curve, the energy power, it depass, or it is more than, or we can say for the 7, the 7 to 7, it depass the power used in home. So the problem that this system will never give us a continue, energy. And the solution here is to store the storage energy for the small system, or for also I will show you for the big system or huge system. And there is only another solution is the diversify the mixed energy mix. So this is the two approach to hit the intermittency of systems. So during the day, excess power from the array is sold to utility. At night, the deficit purchase of from the utility. So or we can buy it to the grid, but this is very complicated, and it affected the grid. But if we arrive to do this, and I think this is in India, we have this case in India, but it's not so efficient, especially when we have a lot of, micro system. And like this, the rooftops. So if each one can inject the result in the grid, so we'll have a lot of problems, because we need to, we need a good inverters. We need to give always the huge performance. So in my opinion, for the small systems, I prefer the to inject just at home and not to buy it to the grid, because the German, government find a lot of problems in feed-in tariff, but it's still good, I think, in some countries. But I speak about Morocco. We need to improve our regulatory framework to do this, and then also to certify the PV models to acquire high performance. As you see here, the difference between this connected rooftop solar PV system and the other solar system is the grid connected inverter, which is smart, as you see here, is directly connected to the PV array. The inverter will convert the solar DC power to an AC sine waves that synchronize the AC supply and voltage and frequency, which is connected. So this is some, classification of grid connected inverters. So we have two main part based on use of transformer based on interface with PV array, insulated, not insulated, and micro inverter. As you see here, I will show you. So here we can choose that if we want each panel, we can connect, as you see in the picture, micro inverters, but the cost of maintenance will be higher in this case. Or we can have a central, a little central single or multiple string connected to a single MPPT inverter. So which will play the role of MPPT and still be an inverter. And this is also a good solution. And if we have a power plant, a huge power plant, we can install a central inverter. And also we can see, you can install a system of monitoring to see, difference, we can see the different, you can see we can see the plots of energy. So the problem, as I said, on renewable energy supplies are continuing or repetitive current of energy occurring in natural environment. The initial input power from the renewable energy supplies, solar radiation or wind speed, therefore is outside our control. And that's what I said. And this is the source of intermittency in renewable energy. The solar radiation, we can control it, we can never control it. And we can control the orientation of PV, but the solar and the weather, it's never controlled. Also, the wind speed is never controlled. So these affect the electricity generation in real time and matching supply and demand in the real time domain, it's a challenge, particularly when the generated electricity is connected to the grid. Two ways to overcome this challenge, as I said. The first one is diversify the energy mix, and this is very important. For example, I use the wind station to, to help me, for example, to store the water, the steps, pampered the station. I will explain you the system in the last slide, and the storage. So the diversification, the mix, and the storage. So here, the context of storage, especially in India, we are talking about the grid-connected renewable energy power project created capacity, which is a very high capacity of renewable energy in India. So that's mean that we are in front of a high potential of development and high challenges for how we can store it and how we can use it correctly. So the intermittent nature of solar and wind resources pose problems pertaining to smoothing of power variation, transmission congestion, relief, load shifting, peak cut operation. Synchronization of demand and supply is also a solution. Management of renewable power generating in non-peak hours, addressing the dark curve phenomena. So I will show you what is the dark curve phenomena. And 24/7 electricity at a place where grid has not reached yet, and execution of microgrids and other off-grids. This is some solution, as I said, for to reducing the intermittency. So we have two main solutions, as I said here. We have to diversify or hybridize the energy mix, storing energy, synchronizing of demand and supply, management of renewable generated in non-peak hours. We can generate it in non-peak hours, and we can use it, for example, renewable energy from, for example, 6 a.m. to 6 p.m. And then, we can use other sources of electricity, and also implementation of microgrids in, the areas not reached yet by electricity, and using also microgrids. So as you see here, this the effect of intermittency of renewable energy. Sorry, here, as you see, we don't have, the generation of electricity from the PV, and the same for here. And as you see from, for example, just a small lapse of time, about, I think is about 1 hour, you see here the power given by a PV output of 4 megawatt PV power plant. It's never stable, and it represents a huge challenge for the whole world. And the same here, we can get the energy supply from Surat just for example, 4 p.m. to 7 p.m. and it pass the demand of electricity from 6 p.m. to 5 p.m. But we need to store it, and the storage of energy is very expensive. This is the dark curve. What is mean the dark curve? This is the peak is always in evolution, as you see here, and the non-peak through the years is always in decreasing, as you see here. So we have to minimize this curve peak by finding new solutions for storage, and which are not expensive. So the solution, the methods of energy storage, as you see here, for chemical part, we can use hydrogen, heat, hot water, steam, molten salt, electric capacitors, gravitational water reservoir. We have this kind, or in Morocco, the gravitational, the water reservoirs, and the mechanical liquid air, flywheel, compressed air photosynthesis, we can use biomass, electrochemical batteries. But as you see here, the capacitor are the most who have the power density, but they're still too expensive and unuseful. We can use batteries, but they still also, the capacity or the power density is lower, and also they are expensive, and they cause environmental problems in producing, because they are, I think, unrecyclable. We can recycle them, and this is also the some, you know, capacity of some material used as our, for example, used in our phones, lithium, but this is only for small, you know, capacities, for small stations. And this is the principles of, you know, the charge and discharge. You know, here in the as you see in the discharge, the lithium plus are going to the cathode, and you know, in the charge, the lithium plus are going to anode. So this cycle of you know, the movement is it expressed, and it used to you know, in the, it used to generate electricity by storage. But as I said, it's only for small capacities. So here I have also some solutions on grid interactive systems on site renewable energy system control or local distribution, and this is also a solution. So we cannot, you know, it's not mandatory to inject and you know, make a on-grid system. We can just, you know, use a local distribution. But for example, a residential complex, for example, they can use rooftops, but for their own, you know, it's not injected in the grid. And the other solution, urban microgrids. This is the solution. You can use it in rural area, also rural microgrids, and the large scale utility scale projects, wind, solar, connected to high voltage transmission grid. And we have this in Morocco, but only for the high voltage and the big complexes in wind and solar, especially in wind, because we have a huge potential in Morocco, but also in solar, but we don't have the regulatory framework to inject in the grid, because we need to develop the financial mechanisms and also tariffs of electricity. And that's why the Morocco creates an agency for you know, for looking at the tariffs and try to organize the tariffs, independent agency. So when we talk about off-grid systems, we can use it, as I said, in rural area to get at least electricity, and maybe pumping water in other areas. So this is the solution that we have in Morocco. No, this is in Japan, but in Morocco we have the same, especially when we have a high potential. We have this, you have the sea or the ocean, and then we have the mountains in front of the ocean. So the old principles or the principles of pumped energy transfer station is that we have two poles, one in the top and the other in the bottom. So when we have electricity produced by renewable energy, we can use it directly to run the pumps and pump water from the bottom to up. And this is a kind of hydro, you know, storage of huge energy. And then we need, when we need, for example, electricity, when we need electricity, we just let the water go in. It's the gravitational effect, let it go in from the top to the bottom. And this is the gravitational effect. We can create it to generate electricity. But this solution, it's still economically efficient because we don't need to build the bottom pool, the pool in the bottom, because the sea constitutes it. But we just need to build the pool in the top. and we can reduce, of course, the cost of construction, and we can store the energy. And this station, I think, is in Japan, in Okinawa. We have the same for this, and we are in Morocco trying to, we have the same challenges for India for storing energy. We are trying to do some studies to try to find the potential, firstly, of these steps, because we have a high potential, the highest point in the world, which contain the high potential. We have it in, where is it? And we want the biggest, I think, the biggest solar power plant in Africa. I will send this to Mr. Ratan Kumar, the informations or country profile of energy of Morocco. So to sum up, the intermittency of renewables energy generally, and the wind and solar energy especially, comes from, that we can never control the radiation and the insolation, and we can never control the speed, of the wind speed. So to fight against these challenges, we need to find mechanisms of storage energy, and try to diversify, firstly, the energy mix, the national energy mix. Maybe inject nuclear, use coal, use so many resources. That's in one hand. In the other hand, we can use also, like these technologies, marine steps, pumped energy transfer stations, but they are marine. We can use the off-grid microsystem in rural area. But the most important of all of this, that the solution are always there, but the problems of all of this is the cost of this solution. The first step of all of this, we need to help people, to give them some, financial incentive, financial, mechanisms that will allow them to buy a solar panel. Maybe we can, some government, institutions that will help people to buy this, and this will certainly take the country to the top. Just the financial issue still the big problem, because as you see here, we can store energy, we can surmount this, and we can fight this challenge, which is intermittency. But we just need, some which are very easy, some financial incentive. Maybe we can give some facilitations in the reception of materials. We can make them there. As I visited India, there is a complex in, I don't remember the city, that they make the solar panel with the high, with the high qualifications, and it passed by standardization and tested there. But we have the materials, and we need to research mechanism financials, to resolve mechanism financial issues, and then we can take our country to the top, and help our country to develop, and help every person in the country to get the electricity. And thank you so much. This is my coordinates if you need any question, any report. And I hope that this presentation was useful for you. And I send my talking to Mr. Ratano.
Thank you, Ayub. It was a nice presentation. Now, I would like others to, those who want to put any questions, they can come up with their questions.
Okay.
Participants can unmute yourself and ask any questions.
Yes.
If anyone want to interact with the renewable energy technology available in Morocco, or any information related, you can ask. Very well interact with Ayub sir.
Thanks.
actually, the renewable energy, there you're focusing in which technology, sir? In solar, whether they are
Uh,
concentrating more on flat type or concentrate type in
uh,
Morocco?
in Morocco, we have a high potential for wind. So we have, especially in the coast areas, and we have the thermal in the other areas inside the country. In the coast we have wind, and inside we have thermal, not solar, because we have a high temperature in the season in Morocco, and the weather is so tough. So that's what we use, the thermal, as a main source of renewable energy with the wind.
Okay, okay. So hybrid system you will be using.
What?
Hybrid also you will be using wind.
Yes, exactly. For some stations, we use a hybrid for example, the thermal energy and solar energy. But the problem that we have in Morocco, that the wind power is licensed for the private sector. So investors can came to Morocco and invest in wind power. It's open, and you can
Okay.
only inject and connect to the grid on high voltage, not the medium voltage. And for solar, we are preparing a solar map for Morocco to facilitate this thing to
Mainly
investors.
they prefer for transferring heat energy. They prefer mainly in solar.
Sorry, yeah,
That is mainly they prefer in transferring heat energy, like thermal storage.
for storage, thermal energy.
Oh, thermal energy.
Thermal energy, we use it to generate electricity. We have a big station which name is where's is it? Where's is it? Norwhere's is it?
Mm.
With 518, I think, 586 megawatt in where's is it?
Okay.
This is the huge station in Africa, I think,
Okay.
because we belong to Africa.
That's then some question is there.
We have a question from one of the participants. Here, what happens when sunlight is magnified using a lens on a solar panel? You can see that question in the chat box.
The shade, are you asking for the shade problematic? No?
No,
Not
generally,
generally. If you concentrate that on a solar panel, what will be the problem?
Yeah, if we have the high temperature in the solar panel, the performance is going lower. We have to make sure that we place it in a fixed orientation which guaranteed the normal temperature, because the temperature influence the performance of solar panels.
I think this concept may be useful only when they are preferring more heat. For light
Yes,
energy, it's of
but
no use.
when we have heat, we have the CSP, the concentrated, you know, as I show in the presentation.
Yes. Any questions, Ratan?
I cannot see any questions. Any students or faculty, if they want to ask any questions, they are free to ask. Otherwise, we will go for the group photo.
Okay. I will send you the presentation and also the country profile detailed for Morocco.
Okay, it
And
will be
if you
great.
have any questions,
We
you
will share,
can
sir.
ask me in the mail.
Yes.
Okay,
Okay.
Ratan?
Okay, that will be better. I request everyone to kindly switch on your webcam so that we can have a virtual group photo for the event. There is a link for the attendees. There is a link posted in the chat. Kindly fill that form for your certificate for this event. I have shared the link in the chat box.
Okay, thank you.
No, not for you, Ayub, actually. It is for the participants.
Yeah.
Okay, so we'll go for a virtual group photo. Okay, everyone. Now I would request Mrs. Jency Anita to present the vote of thanks.
Thank you, Ratan sir. We extend our heartfelt gratitude to the Management Administrative Committee and all the authorities of AVIT for their constant encouragement and support in organizing such events, which will enable all the students to participate and learn a lot. I would extend my profound thanks to our principal and vice principals for their support in all our endeavors. And I'm very grateful for our HOD, who has been a source of inspiration and keeps the pace in the positive direction. And my sincere thanks to all the faculty members who coordinated the students. And last but not the least, I would like to thank all the participants without whom this event might not be successful. I would like to wish you all a happy day and stay safe. So before we close, I request you all to fill the feedback form to receive your e-certificates. Thank you.
Thank you, Ayub sir.
Thank you, ma'am.
You are welcome.
Yes, sir. We will have in future also some more events or some other collaborations if possible.
Of course, I'm here to present. Always I'm here. If you need something or some